Practice test part 3. Yep, this is a long practice test. We finally get to a section that's a little more easy, a section that involves vocabulary more than math. So I really like this section. Let's take a look at this one. It says classify the following polynomial. So in order to know how to classify, you got to go to your notes. And that was from this page, classifying polynomials. Let me zoom in. We need to remember that when you classify a polynomial, the first name is based on the degree, the highest exponent, and the last name is based on the number of terms, right? So if you do have a fourth degree polynomial, the first name is quartic. If you have a third degree polynomial, cubic, second degree, quadratic, so on and so on. If you only have one term out there, that's a monomial. Mono means one. If you have two terms out there, like x squared plus 4, that'd be a binomial. Three terms, trinomial. Four or more, we just call polynomial. So with that said, this is a quadratic trinomial. Quadratic because it's a power of 2 trinomial. Now let's say that this was the, let's say it would have power of 3, then it would have been a cubic trinomial. Or let's say you didn't have the -4, if it was just the first two terms, like let's say this was gone, then right there it would just be a quadratic binomial. So I hope this helps. Let's move on. State the degree. This is pretty easy. All you got to do is look at the highest power, which happens to be 5, and select that answer. Easiest problem in the world. Let's move on. State the constant. Well, we know that a constant never changes, which means that it does not have a variable. The constant is the number 5. Technically, positive 5 is your constant. Select that, get a correct answer, and move on to another question. State the leading coefficient. Once again, leading means it's the coefficient, the number in front of the variable that's out in front when your equation or your polynomial is in standard form. So obviously, this is not in standard form. You want the highest power first. So you take this -4x to the 5th and put it out in the front. So -4x to the 5th, and then plus the 9x to the 3rd, and then finally the -2 at the end. And now you could see that your leading coefficient is the -4. Select all true statements. Okay, so the leading coefficient must be positive. Well, let's think about this. Obviously, this is an odd degree function because you have an odd amount of arrows pointing up, odd amount of arrows pointing down. So is it positive or negative? Well, the thing is this. Let's think of the easiest odd degree function, okay, which is y equals x to the 1 power. That's simply y equals x. You could think of y equals mx plus b. It crosses through the origin and you rise 1, run 1. So this would be your y equals x line going that way and that way. And that is a odd degree function. And in this case, the leading coefficient, there's an invisible 1 right here. So it is positive. So your end behavior on a positive leading coefficient of an odd degree function will be in quadrant 1 and quadrant 2. And this is obviously not the case. This is in 2 and 4. Which would mean that if you had a negative leading coefficient, then it would flip, okay? So that's what it means. So the leading coefficient must be positive. That is false. Don't pick that one. The degree of this function must be at least 5. Well, it depends on the number of directions that it travels in. So it goes 1 direction, 2, 3. So that's a total of 3. It must be at least 3. So be careful with the wording. As it is right now, that's not true. The degree of this function must be at least 3, not 5. But let's say I reworded this and I said the degree of this function could be 5 without the word least. The degree of this function could be 5. That is a true statement. But it says it must be at least 5. That's false. The number of directions tells you the least degree that it could be. It's going in 1 direction, 2 directions, 3 directions. So it has to be at least 3, a degree of 3. Moving on. The relative minimum and value has the x value of 2. Well, where's the relative minimum value? It's right here, right? Now, why is it not the absolute minimum? because there are points lower than this one. So this is just relative to this area. So it's going down, 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 then it reaches a relative minimum point, then it comes back up. So this is the relative minimum. This is the location 0 on the x, -3 on the y. The relative minimum has the x value of 2? No, this has the x value of 0. The coordinate right here is 0 on the x, -3 on the y. So 0, -3 is the coordinate. So if this would have said the relative minimum has the x value of 0, you would say true. But it's saying that this is the relative minimum. That's not true. That's the relative maximum. So that's not true either. The absolute maximum has the y value of 1. Well, first of all, absolute max means that it is the highest point in the entire graph. There are no other points that are higher than that. So y value, here's the y value of 1. That is a relative minimum, but it's not absolute because there are obviously higher points. The absolute max here is positive infinity, or you would say there is no absolute max because it keeps going higher and higher and higher forever. But anyway, this is not true also. So since all of them were false, this is the only one that you would select. None of these are correct in this case. So on this question, they give you a factor and they want you to select all the other factors. So what I recommend doing is to type this in carefully into Desmos. We already know x minus 2 is a factor, which means that it's going to cross the x-axis at 2, but let's see if we could find anywhere else that it may cross. So be very careful when you type it in. If you do type it in correctly, you will see that you have these answers. You have the answer x equals -1, x equals +1, and x equals 2. And of course, those answers came from a binomial that was set equal to 0. So the answer x equals 2, it came from the binomial x minus 2 that was set equal to 0. And on the instructions, they tell us that this is a factor. They give this to you. What are the other factors? Well, this x equals 1, it came from x minus 1. And last but not least, x equals -1 came from x plus 1. So those are the 3 factors so far. We still need to find the other 2 factors or the other binomial that would produce the other 2 answers, which are clearly imaginary. So what I would do is take these answers, the x equals 2, and put that in with synthetic substitution. So here's my 2, and let's do a list of the coefficients. We have 1 in front of the x to the 5th, a -2 in front of the x to the 4th, a 4 in front of the x to the 3rd, a -8 in front of the x squared, a -5, and a +10. So as you go down, you combine. 1 plus nothing is 1. As you go up, multiply. 2 times 1 is 2. Again, 2 times 1 is 2. And then as you go down, you combine, you get 0. As you go up, 2 times 0 is 0. As you go down, combine. 4 and 0 is 4. As you go up, multiply. 2 times 4 is 8. As you go down, combine. -8 and +8 is 0. As you go up, multiply. 2 times 0 is 0. As you go down, combine. We have -5 and 0 is -5. As you go up, multiply. 2 times -5 is -10. And we are happy that we got 0 as a remainder. Now, let's go to the next answer. The next answer would be x equals 1, and let's plug that in. So I'm just going to write the box and the next answer 1 right there, and I am going to do synthetic substitution once again. So as I go down, I combine. 1 plus nothing is 1. As I go up, I multiply. 1 times 1 is 1. As I go down, I combine. 0 and 1 is 1. As I go up, I multiply. 1 times 1 is 1. As I go down, I combine. 4 and 1 is 5. As I go up, multiply. 1 times 5 is 5. As you go down, combine. 0 and 5 is 5. Whoops, I got my colors switched around. Sorry about that. As I go up, multiply. 1 times 5 is 5. As I go down, I combine, and we're not lucky, but we're happy to see that 0 at the end. So far, we've plugged in the 2. That was that answer. Plugged in the 1 right there. That was from this answer. Now let's plug in x equals -1 into this this list of coefficients. Plug in a -1 right there. And this would drop it down to a quadratic. So 1 coming down will be 1. And then -1 times 1 is -1. As you go down, combine. 1 and -1 is 0. As you go up, multiply. -1 times 0 is 0. As you go down, combine. 5 and 0 is 5. As you go up, multiply. -1 times 5 is -5. And as you go down, combine, you get 0. Now we do have a quadratic right here. It's x squared plus 0x plus 5. And we're kind of lucky that we don't have a b term, right? Because when you have x squared plus 5, like imagine if you did have like a 2 right here. It'd be x squared plus 2x plus 5. Then you'd have to use the quadratic formula to get your imaginary answers. But since it's x squared plus 5, this is a factor, x squared plus 5. And that's where your other two imaginary answers would come from if they were asking you to solve, right? You would set it equal to 0, then you would subtract 5, and you would get the square root of -5, which would be x equals plus or minus I squared of 5. Now the reason why I didn't show that work is because they're not asking for the answers. They're asking for the other factors. So they gave you x equals, or x minus 2 being a factor, and the other three factors that you should select are x minus 1, x plus 1, and x squared plus 5. And going back to that question, it doesn't show all of them, but here's the x plus 1, here's the x minus 1, and there's the x squared plus 5. Number 19, it says rewrite in factored form. So let's graph this on Desmos. Type it in carefully and you should see this beautiful graph right here. They want us to write it in factored form. So remember, they want parenthesis times parenthesis. I mean, you know, something like that, right? But it is a third degree function, so we need 3 answers. And we see 1, 2 answers, but this one, look, it touches. That means that this answer of -3 has a duplicity. The x equals -3 has a duplicity of 2. Duplicity of 2. Okay, so this answer happens 2 times. And over here, x equals -1, that only happens once. So what we really have here, guys, is x equals -3 twice. And also x equals -1. So those are your 3 answers. Where did they come from? And that will be the factored form of that cubic polynomial. So where did these answers right here come from? They came from binomials that were set equal to 0. So this one came from x plus 3, right? X plus 3 equals 0. The next one is x plus 3. It's the same thing because there's a duplicity there. And the last one came from x plus 1 set equal to 0. So all we're going to do is put these together, and that'll be your factored form. X plus 3, and x plus 1. This is the factored form. And on this question, they want us to type it in, right? So it's not multiple choice. You actually have to type it in. X plus 3, and x plus 1. X plus 3, x plus 3, x plus 3, x plus 1. It doesn't matter if you put the x plus 3's first or the x plus 1 first. It should be correct. A third degree polynomial function has a leading coefficient of 1, crosses the x-axis at -3 with duplicity of 2, and also crosses the x-axis at -1. Find that third degree polynomial, but only state the coefficient of x. This is very wordy. We need to really understand what they're asking. So let's start reading through this. It says a third degree polynomial has a leading coefficient of 1. Okay, so we know that third degree polynomials, let's just do a quick sketch here. It's an odd degree function, has a leading coefficient of 1. So I know the end behavior is down here and up here, correct? And then it says it crosses the x-axis at -3. So go to the x-axis, go to -3, and put a dot right there. But it says it has a duplicity of 2. So that must mean that it goes up and it touches and then it comes back down, okay? And then it says it also crosses at -1. Oh man, -1's right there. So let me put a dot right there. And if it crosses, I know it has to cross eventually to go up there to that end behavior. So this is a rough sketch of the third degree polynomial function. But what we do know is that we need to come up with that third degree polynomial function, but only state the coefficient of x. Only state the number in front of x. Okay, well anyway, let's first come up with the polynomial function, and then we'll only state the coefficient of x. So when I take a look at this one right here, where did that answer come from? It came from the answer x equals -3, and it came from the binomial x plus 3 that was set equal to 0, right? And we know that it has a duplicity of 2. So I know that I need another x plus 3 set equal to 0. And last but not least, the -1, x equals -1, where did that come from? It came from x plus 1 being set equal to 0. So we do have our 3 answers here. This is a third degree polynomial function, so that's great. 3 answers, third degree. So let's just put these together. Let's multiply the binomials. Let's first put them together and then multiply them. So instead of working up, I decided to write it up here and then just work it out, and we'll get our polynomial function down here. Let's distribute x times x is x squared, x times 3 is 3x, 3 times x is another 3x, and 3 times 3 is 9. So I really have x squared plus 6x plus 9, and we still need to multiply this quadratic trinomial by this x plus 1 binomial, then we'll have our final answer. X times x to the second is x to the third, x times 6x is 6x squared, x times 9 is 9x. Then multiplying by 1 times x squared is 1x squared, 1 times 6x is 6x, and 1 times 9 is plus 9. So let's combine the like terms. We have a 6x squared and a 1x squared. That'll be a 7x squared. So my final answer, I'm going to write it over here because I ran out of space, x to the third plus 7x squared, and then we have the 9 and the 6, which is 15x, and the 9 is at the very end. So this is my polynomial function, my third degree polynomial function that has that given information, those answers at -3 and at +1, where the -3 had a duplicity of 2. Now, the instructions say only state the coefficient of x. Here's x. You're only going to write +15. So when you look at your answer, there it is. The answer, type in +15 without the x, just the coefficient of x, the 15, hit enter. That'll be your correct answer. I know it's crazy, all this work just to hit 15 and enter, but that's what it's asking. So I hope you're comfortable with this, and I hope you study it and ace the test.